This is a video from section 3.6. Let y equal arc sine x. I want to find the derivative of arc sine x with respect to x. So y equals arc sine x means x equals sine of y, and y is greater than or equal to negative pi over 2 and less than or equal to pi over 2. Y equals arc sine x, that's where we're starting. So x equals sine of y, where y is greater than or equal to negative pi over 2 and less than or equal to pi over 2. We're going to differentiate both sides with respect to x. So the derivative of x with respect to x is the same as the derivative of sine of y with respect to x, which says 1 equals cosine y dy dx. Solving for dy dx, we get dy dx is equal to 1 over cosine y. Since y is greater than or equal to negative pi over 2 and less than or equal to pi over 2, we know cosine y has to be greater than or equal to 0. Now, cosine squared y plus sine squared y is equal to 1. Subtract sine squared y on both sides, and we get cosine squared y is 1 minus sine squared y. Solving for cosine y, we get cosine of y is equal to square root of 1 minus sine squared y. And what we're going to do is replace cosine y with square root of 1 minus sine squared y. So dy dx is equal to 1 over the square root of 1 minus sine squared y. But x equals sine of y, so dy dx is equal to 1 over square root of 1 minus x squared. And thus we have shown that the derivative of arc sine x with respect to x is 1 over the square root of 1 minus x squared. So that's how we would derive that. Now let y equal arc cosine x, and I want to find the derivative of arc cosine x with respect to x. Now, y equals arc cosine x means x equals cosine y, and y is greater than or equal to 0 and less than or equal to pi. So we're going to, again, start with y equals arc cosine x. And so x equals cosine y, where y is greater than or equal to 0 and less than or equal to pi. And we're going to differentiate both sides with respect to x. So the derivative of x with respect to x is the same as the derivative of cosine y with respect to x. So 1 equals negative sine y dy dx. And if we solve for dy dx, we get the following. Dy dx is equal to negative 1 over sine of y. Since y is greater than or equal to 0 and less than or equal to pi, we know sine of y has to be greater than or equal to 0. And again, we're going to start with the Pythagorean identity that sine squared y plus cosine squared y is equal to 1. Sine squared y is equal to 1 minus cosine squared y, so I just subtracted cosine squared y on both sides. Solving for sine of y, we get sine of y is the square root of 1 minus cosine squared y. So dy dx is negative 1 over the square root of 1 minus cosine squared y. And again, I just replaced sine of y with the square root of 1 minus cosine squared y. Now, x equals cosine y, so dy dx is negative 1 over the square root of 1 minus x squared. And we have thus shown that the derivative of arc cosine x with respect to x is negative 1 over the square root of 1 minus x squared. Let y equal arc tangent x, and we want to find the derivative of arc tangent x with respect to x. So y equals arc tangent x means x equals tangent y, and y is between negative pi over 2 and pi over 2. And this is a strict inequality, so in other words, y is greater than negative pi over 2 and less than pi over 2. We'll start here with y equals arctangent x. And so that means x equals tangent y. And we're going to differentiate both sides with respect to x. So the derivative of x with respect to x is the same as the derivative of tangent y with respect to x. So 1 equals secant squared y times dy dx right here. And they all have a very similar derivation to each other. So I'm doing a very similar process here. So solving for dy dx, I get dy dx is equal to 1 over secant squared y. But remember, 1 plus tangent squared y is equal to secant squared y. And so I'm going to replace secant squared y with 1 plus tangent squared y. And so dy dx is 1 over 1 plus tangent squared y. But x equals tangent y. And so therefore dy dx is 1 over 1 plus x squared. And so therefore the derivative of arctangent x with respect to x is 1 over 1 plus x squared. And that one does come up, especially when you get into calculus 2 and differential equations. In fact, all three of these derivations will appear again. You will see this again when you hit calculus 2 differential equations. So these would be very good for you to know. Let's look at some examples. The directions say to find the derivative of the function, simplify where possible. And with that, we're going to take a look at number 63. So here we have f of x is equal to arc sine of 5x. Now, remember here that the inside function is the argument of the arcsine. So in other words, the inside function will be, we'll call it h of x is equal to 5x. Okay? So when we look at the derivative, now the derivative of the arcsine function will be 1 over the square root of 1 minus, but again, we're going to evaluate at the inside function. So I need to replace that x with 5x. So I'm going to take 1 over the square root of 1 minus 5x to the second, and I'm going to multiply by the derivative of the inside function with respect to x. So in other words, I'm going to multiply by the derivative of 5x with respect to x. Now, 5x quantity squared is 25x squared. And so therefore, f prime of x is 1 over the square root of 1 minus 25x squared times the derivative of 5x with respect to x is 5. So I'm going to put a 5 here. And so therefore, f prime of x is 5 divided by the square root of 1 minus 25x squared. Now, one warning I have about this kind of problem, let's put a note here. 5 over the square root of 1 minus 25x squared is not the same as 5 over the square root of 1 minus the square root of 25x squared. So this is completely correct. But if I were to see this, it would be marked completely incorrect. And so we want to be very careful here. Okay? Let's take a look at 65. Suppose y equals the arctangent of the square root of x minus 1. Now, I want to find dy dx. So this is going to be 1 over 1 plus the inside function squared. So in other words, I'm going to take 1 plus the square root of x minus 1 squared. And I'm going to take this result and I'm going to multiply by the derivative of the inside function with respect to x. So in other words, I'm going to multiply by the derivative of square root of x minus 1 with respect to x. So this is 1 over 1 plus the square root of x minus 1 to the second is just x minus 1. And I'm going to take this and I'm going to multiply by. Now remember, square root of x minus 1 is the same as x minus 1 to the half. Okay? And so this is going to be multiplied by 1/2 of x minus 1 to the negative 1/2 times the derivative of the inside function, which in this case will be x minus 1. So we're going to multiply by the derivative of x minus 1 with respect to x. So the 1's cancel, and we get 1 over x times 1 over 2 times x minus 1 to the half times 1. And I'm just going to write this a little bit simpler here. So therefore, dy dx is 1 over 2x times the square root of x minus 1. That's number 65. 66. Suppose y equals arctangent of x squared. And I want dy dx. So I'm going to take 1 over 1 plus the inside function squared times the derivative of the inside function with respect to x. And so in the last two problems, let's go back here. I'm replacing the x with whatever that inside function is, and then multiplying by the derivative of the inside function with respect to x. Okay? So the inside function here will be x squared. So I'm going to put an x squared here and an x squared here. And so therefore dy dx is 1 over 1 plus x to the 4th, right? Because 2 times 2 is 4, times 2x. And so therefore dy dx is 2x divided by 1 plus x to the 4th. That's 66. Let's take a look at 67. Suppose y equals arctangent x to the second. Now, the inside function here will be arctangent x, which we can say is g of x, right? So when I want dy dx, I'm going to get 2 times the inside function, which is arctangent x to the first, right? And I'm going to take this result and I'm going to multiply by the derivative with respect to x of the inside function. Just like this. And so dy dx is 2 times arctangent x times 1 over 1 plus x squared. And that's going to take time to get comfortable with that derivative. Okay? So it will take time. So therefore, dy dx is 2 times arctangent x divided by 1 plus x squared. That's 67. Let's take a look at 68. Suppose g of x is arc cosine of square root of x. Now, remember, square root of x is the same as x to the half, okay? So I want g prime of x. Now, again, I want to refer you back here. So we're going back a few pages. Notice that the derivative of arc cosine x with respect to x is negative 1 over the square root of 1 minus x squared. So remember, the argument of the arc cosine is now square root of x. And so I'm going to replace the x with square root of x. Okay? So let's go back here. A few pages up. And so I'm going to get negative 1 over the square root of 1 minus, and again, I'm going to replace x with square root of x and raise it to the second power, and I'm going to multiply by the derivative of square root of x with respect to x. And so g prime of x is 1 over the square root of 1 minus x, and that's negative, times 1/2 x to the negative 1/2. So that's just power rule to take the derivative of square root of x. And so this is negative 1 over 2 square root of x times square root of 1 minus x. And I will leave it up to your instructor as to how far they want you to simplify. And so we'll leave 68 right here. So I would ask your instructor as to how far they want you to simplify with that particular problem. And let's take a look at one more for this video. So on 69, we have h of x is equal to arc sine x, or inverse sine x, times natural log of x. So this is a classic product rule problem. So when I want h prime of x, I'm going to write down the first function, which is arc sine x, and I'm going to take the derivative of natural log of x with respect to x, which in this case is 1 over x. And then I'm going to write down the second function, which is natural log of x, and I'm going to take the derivative of the first function with respect to x, which is 1 over the square root of 1 minus x squared. And so this is arc sine x divided by x plus natural log of x divided by square root of 1 minus x squared. And many instructors, I would say, probably like a common denominator here. And so if that were the case, you can write it this way. So h prime of x is arc sine x times the square root of 1 minus x squared plus x times natural log of x, and then I'm going to divide by x times the square root of 1 minus x squared. So that's how you would write it as a single fraction. And that'll do it for this video. This is section 3.6, and we worked on problems 63, 65, 66, 67, 68, and 69. Thank you.